Hi everyone, you're welcome to the Trilinear Math. In today's video, the problem before us is to determine whether the following converges or diverges. First, before we proceed, with the question, take a look at this, the sum. Take a look at the discrete sum. This discrete sum we have here. What we have at the denominator is 2n, and what we have at the numerator is 3 raised to n plus 5. Is there a way we can actually put this in the form of, say, summation x raised to n? For instance, if we had this to be 2 raised to n, we can actually say, okay, maybe we should just put 3 raised to n over 2 raised to n and plus 5 over 2 raised to n together, for which we can just think of this as 3 over 2 raised to n and try to do this here. I mean, look at this from the standpoint of this being a common ratio r, okay? But that's not what we have here. So what we'll do here is we'll use the limit ratio test. So to say that an r is equal to limits, we'll take limits because we can't 2n factorial is here and 3 raised to n factorial, 3 raised to n is here. So we'll say take the limit as n goes to infinity of an plus 1 over the absolute value of an plus 1 over an. Absolute value of an plus 1 over an. Okay. Now, so what we just do here is to say 3n was our and we'll have to take limits since we're taking a sum from 1 to infinity. So the first an here, an plus 1 over an will be equals to, putting for an plus 1, putting n plus 1 here, we have 3 raised to n plus 1, okay, plus 5 over 2 into bracket n plus 1, okay, factorial over, this is the an plus 1 term, over 3 raised to n plus 5 over 2 into bracket n factorial. So lim as n goes to infinity. Now take a look. What we'll have here, we'll have 3 raised to n plus 1 plus 5 over 2 times n plus 2 factorial. Divide this by this. We have 2n factorial over 3n plus 5. Now, let's put in the factorials together and then the constants together. See, 3n plus 1 plus 5 over 3n plus 5 times 2n factorial over 2n plus 2 factorial. Take a look. Let's evaluate this. This will become 2n times 2 n minus 1 times 2n minus 2, okay, 1 and 1 in that order, over, we have 2n plus 2 times 2n plus 1. We'll keep dropping the terms into brackets, 2n times, it keeps going in that order, times 3 times 2 times 1. 2n, and then we have 2n minus 1, 2n minus 1, keep going in that order, times 3 times 2 times 1. Okay. In fact, we can actually stop. And now let's cancel. We have 2n cancel 2n, 2n minus 1 cancel 2n minus 1, 2n minus 2 cancel 2n minus 2. We'll keep going. 3 cancel 3, 2 cancel 2, 1 cancel, and then we're left with just on this side 1 over 2n plus 2 into brackets 2n plus 1. Okay, let's bring down this 3n plus 1 plus 5 over 3n plus 5. Okay, so this is what we have. Now, so what we'll do now is to take limits. The next thing is to take limits as n goes to infinity. If we take limit as n goes to infinity, take a look at this expression here. What is the lowest power here? Okay, to find the lowest power of n here is 3 raised to the power n. So we'll use this to divide all of the term we have here. So we'll say 3 raised to the power n plus 1 over 3n plus 5 over 3 raised to the power n over 3 raised to the power n over 3 raised to the power of n plus 5 over 3 raised to the power of n. And we have 1 over 2n plus 2, 2n plus 1. Okay. In fact, yes. Let's evaluate what we have here and then see how we can take limit. Let's evaluate what we have here and then we'll take the limit. This cancel this is 1. Okay, so what we'll have will be, let's do, okay. And the limit as n goes to infinity, we'll have 3 here. 3 cancel 3. This is 3 raised to the power n times 3. Plus 1 is as good as saying 3 raised to the power n times 3. Okay, indices. So we'll be left with 3 plus 5 over 3 raised to the power n over 3n cancel 3. 3 raised to the power n cancel. We'll have 1 here plus 5 over 3 raised to the power n and times 1 over 2n plus 2 into brackets 2n plus 1. So in the limit as n goes to infinity, 3n will go to infinity and all of this value goes to what? 0. All of the same thing applies here. All of this will also go to what? 0. And then if this is, since this is infinity and infinity, okay, as this number get large, n get large and n get large, all of this, the denominator here will tend to, so we'll have, all of this will go to 0, all of this will go to 0, so we'll have 3 times, all of this goes to 0, and we'll have 1 divided by a large number will give us 0. So therefore, r, it's equals to what? 0. So recall, since our r is equals to 0, and which is less than the absolute, which is less than 1, okay, hence we say that this series here, once it's less than 1, we say that it is what? It converges. The sum of the series here, okay, we say that it converges. So I hope this helps. If you've not yet subscribed, please do so. It helps us to make more content. If you have any questions, feel free to put it at the comment section or send it via direct message. I'll be more than happy to respond. Thank you all for watching and staying with me up to this moment. I'll see you all in the next one. Bye.